I start today's class with a show of hands or raise your hands if anyone is completely new to networking. Is there anyone who is completely new to networking and he's just starting, he or she is just starting their
Yeah,
journey today?
I am. I'm starting.
No
So,
problem. Just raise your hand. That's
oh,
okay. And I would ask everyone to please go on mute because that sometimes disrupts my flow of thought. All right. So there are quite a lot of people who are completely new. Okay. So I ask them this question. How did you know about CCNA? I mean, are you aware what CCNA is, or just by the word of mouth from your friends or from someone, your colleagues, or just you read something on the internet, you just said this certification or this particular course would give me a start? How did you know about CCNA? Anyone who has raised their hands who are completely new to this, I would like to know from them.
Hi, sir.
Yeah, Martin.
Yeah, actually, whenever we finish the college and when we get to career opportunity to the IT field or networking field, that time we will aware about that CCNA is the basic of networking courses. So I get it from there whenever get a job, first job.
Mhm.
So from there I heard about this.
Okay, right. All right. So thank you, Martin. Thank you for that. And I'm pretty sure most of you guys who have raised their hand, they would have heard like this only, right? In their company or from their friends or in the college, some professor would have said, right? So all is correct. And if anyone is already from a computer science background or an electronics and telecommunication background or EC that we call in some states, right? So they would have already heard about computer networks in their college curriculum. So today, the whole session is going to be about what is computer networks and why do we use computer networks and how do we use the computer networks. Okay, so this is an introductory class. Okay, so there's going to be very basic as to uh, how and where do we see these computer networks in our daily life. That is what the discussion is going to be for today. Okay, is my audio clear? I see some people saying my audio is not clear.
No, it's clear, Laksh.
All right, thank you. And I will ask everyone to please go on mute. I see some people are not muted. Please, I would request you guys to go on mute. All right. So let me share my screen. Okay. So as on the screen, you can see computer networks, what, why, and how. So let me again introduce myself. My name is Laksh. I work for Cisco. I have 9 years of experience, and I've completed my CCNA, CCNP, and CCI service provider return. So let's get started with that. So we all know that we always use internet. Okay, we always use internet to do some of our basic stuffs. Nowadays, without an internet, we cannot even kill our time. Right? So we use Facebook, we use Google, we use Netflix, we watch sports. All of that is running over the internet. So all the discussion that I'm going to do today is based on real-time examples. So on the screen, you can see uh, there are two people. You can imagine one as yourself and the other person as your friend. So this is you and this is your friend. Right? Now, basically, what we always see is that even now you are connected to you are connected to internet via mobile. I'm connected to the internet via Wi-Fi router, right? And that is all that is visible to us, right? So my laptop is connected to a Wi-Fi router and it is sending the signals, right? That's all that is visible. Similarly, your laptop or your phone is connected to your Wi-Fi router and it's sending some signals. That is all that you are aware of. But there are a lot of things that goes after or beyond the Wi-Fi router. So here, these are the Wi-Fi routers of our homes. And what happens between these two Wi-Fi routers? How do they send a message? For example, your friend or me or yourself, you send a hi over Facebook or over WhatsApp. It goes to your friend's mobile phone or whatever application that he is using, and he can read your message. Also, you will be able to find out if he has read the message, if he has seen the message, or if your message has been received to your has been sent to your friend's phone or not. All that information that is being exchanged between your friend's phone and your phone is what computer networks all about. The study of that, how two devices talk over a network or a wire, is the study of computer networks. Okay. Now, before we jump into that discussion, and if you guys have any doubts, feel free to ask me anytime, interrupt me anytime, and ask question. Right now, before I move on, I wanted to know what you guys understand by the word internet. All of us always use this term internet in our daily lives, right? What do we, or what do you understand by internet? Can someone tell me?
It's like a network of networks.
All right. Someone said network of network. Let me note that down. Network of networks. Anyone else? What do you mean by internet? You can speak up. It's like, sometimes I may not be reading the messages. So someone has said interconnection of networks. Yes. Interconnection of networks. Anyone else? Let's make this interactive.
Hi.
Yeah.
Hi, good evening. So, basically, network is networks of network. So, we can communicate to each other with the help of network.
All right. So communication with networks. All right. So all of these answers are subjective. The word internet itself is a very subjective. Okay, there's no definite answer to it. So that's why all these answers are correct. Right now, before we actually jump onto the actual definition of internet, let's just look into this diagram. Okay, so you can see that there are a lot of devices, right? You can see laptop, you can see a mobile phone, sorry, a telephone, a mobile phone, a server, right? And not just this, these servers are connected to each other. These devices are connected to each other. Similarly, not just them, there are other devices who are connected to each other, and they're forming their own small group of interconnection, right? And these small devices themselves are forming a group, and that group in computers, right, in the terminology of computer, is called as a network of devices, right? So let's take the example of your home, right? You have a Wi-Fi router, right? And that Wi-Fi router is sending signals. And using the Wi-Fi router, your mobile phone is connected. You have a smart TV that is also connected. And if your parents are using a mobile phone, they are also connected to the Wi-Fi router. You are using a laptop that is connected to the Wi-Fi router. So what is happening? All of these devices have formed a small network of their home of their own, right? So not only these devices can talk within themselves, they can talk to a network which is outside their Wi-Fi router's connectivity, right? So for example, you are talking to someone, let's say you're talking to your cousin. Your cousin obviously is not living with you. He is living somewhere else, right? So even he or she has a Wi-Fi router in their home, right? And that Wi-Fi router is again connecting different smart devices together, right? So this itself is a small network, and these two, so you can talk intra network, you can talk among themselves within your own network, and you can also talk inter network, right? And that is what you mean by internet. Interconnectivity or intercommunication of networks is called as internet. So many people think Google is internet. That is what people say. Go to Google. Google is internet. No, Google is not internet. Okay. Internet is a connectivity of two different networks. Internet is, in other words, is a path to reach Google network. Google in itself is a small network, not small, it's a big network, right? Google is a network. Amazon is a network, right? Netflix is a network. Our Network King's website itself is a network, right? So connecting these networks is what you call internet. And how are these devices or how are these networks connected together is the study of computer networks, which basically is told in your CCNA, CCNP, and CCI subjects. Okay. Any question up till here?
Yes, sir.
Yeah.
I have a question. What is the difference between internet and intranet?
Okay. Please mute yourself. Everyone, please mute yourself because I can hear echo. Ankit, yeah, please mute yourself. Thank you. So when I say, okay, do you play sport? Any sport, right? So we have in our school days, right? We had inter-school competitions. Inter-school competitions. What do we mean by inter here? That means this is school number 1 and this is school number 2. So the competition is between two different schools, and that's what we call it as inter-school. Similarly, international. When we say international, that means two different countries, right? Now, when I'm talking of intra, when I say intra, it means within the same school. So when you have, like, we in my school time, we had 4 different houses, right? House number 1, 2, 3, 4, right? So the competitions was happening between the 4 houses. So basically the competition is happening inside the school, and that's what we call it as intra. So similarly, intra communication means communication within the same network. Intercommunication means communication between two different networks. I hope that made sense. Any other question?
Hi, Laksh. If it is like intranet, can we think it is like within the LAN communication like that?
Yeah, you can.
Okay.
All right. So today we'll understand the all our real-time examples through two of the most famous rules. Okay, I would say rules, right? Rules of computer networks. So just like are traffic rules. Okay, so for example, you're standing at a traffic signal, right? It's a 4-cross traffic signal, 4-cross road traffic signal, right? So what basically happens is, here is a traffic signal, right? Now, what basically a traffic signal do? It basically helps in controlling the flow of traffic. Correct. Red means people should stop. Green means people should go. Right. Turn right signal is there, then people should only turn right. If both straight and right is there, then that means people can go straight and right as well. Right. Now, just imagine, not just imagine, we always say this. If the traffic signal is not there or people are not following the traffic rules, what happens? There is basically a traffic jam. Nobody can go. It basically gets stuck, right? So this is in the human world. Okay, human are easy to control, right? You just put some challan, they'll start behaving properly. But what about computers? They're machines. They understand only bits and bytes, basically ones and zeros, right? They only understand these binary values. To make them understand, okay, because we created them, we want two devices to talk to each other, but there should be some rules and regulations that they should follow in order for the two devices to talk. And those two rules and regulations, sorry, not two, those rules and regulations are defined by these two models. Okay, OSI. OSI is called as Open Standard Interconnect. Okay, this is one particular model which creates the set of rules with which two devices can talk. Another is TCP/IP model, which basically is Transport Control Protocol / Internet Protocol. IP stands for Internet Protocol. Using these two protocols only, your two devices, any device, it can be your mobile phone, it can be your laptop, it can be a server, it can be even your smart TV, right? Anything that gets connected to the internet, anything that can talk to different networks or even within the same network, need to follow some rules and regulations. Those rules and regulations are given by these two models. Okay, so based on these two models, we'll understand where are these rules applied in day-to-day life. Right. Now, here you see
Hello, Lak.
this. Yeah.
Yeah, I want to ask one question. ये OSI is Open Standard Interconnect or it is Open System Interconnect?
You can call it anything. It can be open. It's an open standard. Okay, it's open. You can call it open system also. Basic what is open standard or open system? It's not a proprietary thing. It's for all.
Okay.
Right. So open standard or open system, anything is fine. Now, in front of you, okay, this is especially for people who are completely new to the internet or the world of networks. You can see there are 7 different layers. Okay. Now, these layers are present in each and every networking device. It can be your phone, it can be your laptop, it can be your smart TV, it can be your PC. Anything that is capable of getting connected to internet, these layers are present inside your device. They are hard coded on your chip, on your microprocessor or ICs, right? They are hard coded there, right? Now, where and when are these layers come into picture? That is what we are going to understand now. Okay, I am taking all this. The reason is, when we are talking about networks, it's better to understand how these different layers are being seen in everyday life. Then only you will be able to relate why and how important is it to understand the networking concepts, right? So you see, there are 7 different layers. These 7 different layers are part of your OSI model that I said earlier, just now. Open Standard Interconnect or Open System Interconnect. The difference between OSI layer model and TCP IP model is that in TCP IP model, these top 3 layers, session layer, presentation layer, and application layer, are grouped together into a single layer as layer 5. And they are called as application layer. That's the only difference between OSI layer model and TCP IP layer model. The rules and regulations remain the same. How different layers work remains the same. There is no other, the working remains the same. The only difference is the upper 3 layers are grouped together as one single layer as layer 5 and are called as application layer. In OSI layer model, they are segregated into 3 different layers: session, presentation, and application. Okay. Now, okay. So let's just understand first a very basic concept. Let's imagine you are using WhatsApp application on your phone. This is you. Okay. And this is your friend. He is also using WhatsApp. Okay. This is your friend's WhatsApp application. WhatsApp is an application. So it is running at your application layer on your phone. Even on your friend's phone, application, any application that you run on your laptop, on your phone, on your smart TV, everything, it runs on your application layer. That's why it's called an as application layer, right? Now, when you typed hi on your WhatsApp, right, it reaches your friend's phone and you can see some tick marks. It has been sent, it has been received on your friend's phone, it has been seen by your friend. All 3 types of messages can be seen on your phone, right? How does it happen? So we'll understand that one by one. So first, what happens is that when you type any message, it is being typed at the application layer. Now, the basic fundamental is that, is someone saying anything? Sandeep, are you trying to say anything? If not, please go on mute. I see there are a lot of people who are not on mute. Please be on mute. Thank you.
So what was the 5th layer of TCP IP just now you told?
It's called as it's called as application layer.
Okay.
5th
And
layer
what
in
is
the
it?
TCP IP layer is called as the application layer.
Okay. And full form of TCP is?
Transport Control Protocol. Transport Control Protocol.
Transport or transmission?
Transmission control, transport control, anything is fine.
Okay.
You'll understand why is it called transport or transmission interchangeably in some time. All right. Now, when you type hi, it is basically written on your application layer. In any networking device, the device is basically programmed such that your higher layer information, again, I'm emphasizing on the word higher layer information. Your higher layer information is encapsulated inside your lower layer information. I said the word encapsulation. Okay. Encapsulation. Encapsulation means, what is a capsule? Obviously, we have taken a lot of capsules, right? When we are sick, We take a lot of capsules. Inside the capsules, there are very small balls, right? They are basically the medicines. The capsule is just the cover. So yeah, you can call encapsulation as envelope also, right? Envelope, right? So your higher layer information is enveloped inside your lower layer information. So your high message at application layer is encapsulated at by the presentation layer, right? This presentation layer is then encapsulated inside session layer, then your transport layer, network layer, data link layer, and your physical layer like this. At your physical, we'll come to these layers in some time. One by one, we'll come to this part, right? So at the physical layer, what happens is that all these information that is being passed down up till your data link layer is all binary numbers, basically ones and zeros or combination of ones and zeros, right? At your physical layer, what happens? This, your laptop, for example, your laptop or your mobile phone, right? It is sending information in the form of waves, right? Signals. So either it can be signals, it can be wireless signals, or it can be wired signals through wires. So if it is wires, it will be sending signals as electrical signals or light signals, right? And then it crosses some kind of distance. It goes through different networks. It can be intra-network, it can be inter-network, anything. And then this information reaches your friend's phone's physical layer. So if your friend is using a Wi-Fi signal, that this message, hi message, in the form of signals, if it is wireless, in the form of signals, if it is wired, in the form of electrical signals or light signals, reaches your friend's phones or laptops physical layer. In this physical layer, it then again is converted back to ones and zeros, right? So now whatever information at your side was being enveloped or encapsulated at your friend's side starts to get decapsulated. It is called as decapsulation. Decapsulate or de-envelope. So first at your physical layer, the information is converted, right, into binary forms, and slowly first your second layer is read, third layer, fourth layer, fifth, sixth, and finally, and at your seventh layer, when this seventh layer opens up the message, he would read the high message that is being sent to you, sent by you. I'm sorry. Right. So now what we're going to do, this was just how your devices basically send information. Okay. Now what we're going to do is we are going to go one by one at each and every layer. And how are these layers, or how do we see these layers physically or virtually everywhere? Right. Any questions up till now? Am I audible to everyone?
Yes, you are.
Yeah, you are audible, sir.
All right. All right. Okay. So no one has any doubts. I move on.
Till data
If-
link layer, the data is in the format of binary, right? From a sender side.
Till data, no. It's at the data link layer, at your data link layer, before it sends to the physical layer. Yeah, till data link layer, it's in the binary form. At the physical layer, it gets converted either in
Signals or
radio
waves.
signals,
Yes,
radio
yes.
signals, electrical signals, or light signals.
Okay.
Hello, sir.
Yeah.
I have one question.
Yeah.
So, modem works which layer, sir? It is work physical layer or data link layer?
You're talking about your Wi-Fi modem
Yeah, modem.
at your home. See,
Yeah,
Wi-Fi
modem.
modem inside, even inside your Wi-Fi modem, these layers are present. Okay.
Okay.
For
So
your Wi-Fi modem, what is a physical layer? It's
no,
the
I'm sir. I'm sorry for that. Actually,
Hmm.
I'm asking, sir. A modem is works, sir. Which layer, sir? A physical layer or data link?
That's what. See,
Okay.
I'm saying that your layers, okay, these layers, your devices do not work on a particular layer. Okay, these layers are present inside your device. Okay, and based on the capability of that device, it will read those information. So your Wi-Fi modem can work up till 4th layer. Your antenna, your Wi-Fi modem's antenna is physical layer. Your Wi-Fi modem's MAC address is data link layer. Your Wi-Fi modem's IP address is network layer. And whatever information that is being passed between you and me, you and the Netflix server, you or the Google server is working at the transport layer. So we cannot segregate any networking device based on a layer. The question basically, I would say, is wrong. At what layer a particular device runs is a completely wrong question.
So, but I have one doubt. I have heard people asking questions like, suppose there is a X device like a switch or a router. There have been questions people ask like, this router is which layer device or switch is a which layer device. Then why these people are questions like this present?
See, I would say the question is not wrong. Probably it is how people have been asking them. It is how they have been taught, or they have read, or they have shared information.
Right. Because I have also faced one question like that. Someone asked me that this
Yeah.
L2 is
No.
a L.
So the question should be, how many layers can the router support? How many layers can the switch support? How many layers can your mobile phone support?
Okay, this is a
The
better one,
questions
right?
should be like this,
Right.
rather than router. At what layer does the router run? No, router can run at many layers. It can even run till application layer. It depends on what kind of application is it using. So router can run at layer 7 also. Not only layer 3, it can run at layer 7 also. BGP, the person, I'm not sure who asked me this question. If you have heard of BGP, BGP is a layer 7 protocol. Routers run BGP.
Yeah.
Right.
That's correct.
Right.
Actually, sir,
So
someone
the question
asked
is,
me.
the question should be, what layers do these devices support? Okay.
Sir, I have small question.
Yeah.
So after reaching data link layer, these bits get converted into, for example, assume that I'm using Wi-Fi. So after reaching this data link layer, how these bits get converted? It will get converted into RF signals, or
See, here, for example, let's say these are electrical signals. Okay. So here you have a wire connected to your laptop. So
yes.
at this layer itself, till here, it was all electrical signals or light signals if it's a fiber layer, optical cable.
Yes,
Right.
yes.
At the physical layer, there's a demux. Right. Mux, demux. Okay. Even I'm not that of an electrical guy, but there should be some deconverter of those signals. So at the physical layer, your light signals gets converted into binary form and is sent to the upper layer then.
Okay. Now my question is, like, if we are using Wi-Fi, how it's get connected from sender side? These bits converted into radio frequency signals or any other signals?
Yes. Your phone, my laptop is sending information to my Wi-Fi modem or your Wi-Fi modem in radio frequencies.
Okay.
Your Wi-Fi modem converts these radio frequencies into light signals or electrical signals and then passes it on.
Okay. Thank you.
Right. Now, coming to our first layer.
Sorry to interrupt. I have a doubt. So is that the physical layer converts the data into binary, so it transmits the binary data through the electrical medium or the optical medium.
Yes, yes.
So it is not converting, right? It's transmitting the binary data.
Yeah. Conversion is already happened at the mux or like the converter. They are just the transmission medias.
Okay. Yeah. And coming to the other layers, I think up to fifth layer, the PDU will be data, and at the section layer, it will be packets, and transport layer, it will be frames, right?
No.
Then
I'll come to that. Don't worry. I'll come to that.
Okay.
Yeah.
Hey, Lex, can you hear me?
Yes, Sharvin, but your voice is too low.
Yeah. Now, can you hear me?
Yeah.
Okay, so the data link as divided into two, right? Two more layers, like a MAC and LLC. Do you want to elaborate more now, or like you will be covering later?
I'll cover that later.
Okay.
Yeah. So coming to the first layer, the physical layer. Okay. On the screen, you can see there are different type of cables, right? So you can see we have an audio video cable. This is a fiber optic cable. This is a USB cable, HDMI. Sorry, this is an HDMI cable. This is a RJ45 CAT cable, etc. And this is our USB B or C cable, right? So we always use cables in order to transmit data. In order to transmit the data, we use a lot of cables, right? And where have we witnessed these cables the first time? Probably when when at our home we had a landline phone, right? In our landline phone, right, the connection would have been something like this, the landline phone. And in our computer labs, we would have seen a LAN cable like this. Or for our TV, when we have the satellite cable TV connection, we would have had this kind of cables, right? So without even today, 90% of the world is connected through wire. Without wire medium, internet is not possible. Interconnectivity is not possible. I will not be able to talk to you. You will not be able to hear me without internet and without wires. Okay. You can ask, you can say, I'm using phone, a mobile phone. I'm connected through the Wi-Fi. I'm not connected through a wire. You can also say, I'm connected through my data, internet data. I'm not using my Wi-Fi modem. I'm directly using my internet. I'm still not connected to wire. But again, let me just give you an example. My laptop, right, is connected to my Wi-Fi modem. Right? The Wi-Fi modem at your home also is connected through a cable, probably a fiber optic cable or an RJ45 or a what do you say? Forgot the name. Sorry, I forgot the name. It is connected to a cable.
Copper cable.
Copper cable, fiber cable, or an RJ45 cable, any Ethernet cable, right? So, and then it is then sending these signals to the nearest device. Again, this is a wire. Your wireless connectivity is only limited up till here. The second scenario is you're using internet, your data internet, not your broadband internet, but your data internet. Your phone, okay, your phone is basically sending information to the nearest mobile tower, right? And this mobile tower is then receiving that information and sending information through a wire to the next mobile tower. Again, they are connected through wires. So as I said, most of these devices or your networking devices are connected through wires, and without wires, internet today is not at all possible. Right. So Siddhi, please be on mute.
मैं बोला ना तुम अपडेट होने टाइम वो और
All right. Now, coming to the second layer. Okay. Coming to the second layer. That is the data link layer. Okay.
सर RJ45 और कॉपर में क्या डिफरेंस है?
बेसिकली देखो RJ45 एक just you see this not yeah ये वाला this one RJ45 मैं डायग्राम दिखा देता हूँ. I'm sure you would have seen these cables. These are your RJ45 cables. Okay. Now, there is no difference between RJ45 and a copper. The thing is, the wires, the way they transmit the information, right? This is only RJ45. This part is only RJ45, right? And inside these wires, they are made of copper wires. That is why they are called as copper cables, right? So if you ask me what is the difference between RJ45 cable and a copper cable, a copper RJ45 cable is made of copper cables, and there are different types of copper cables. You have twisted copper cable, untwisted copper cable. You have all those things you would have read, right? And we'll see that in tomorrow's class.
ये Ethernet केबल है ना, इंटरनेट प्रोवाइड करने वाली.
ये ईथरनेट केबल बहुत ही कॉमन टर्म है. ईथरनेट केबल नहीं बोलते, टेक्निकल टर्म इसका RJ45 केबल है.
तो मतलब ईथरनेट केबल कुछ नहीं होती, वो RJ45 केबल्स होती है जो राउटर से कंप्यूटर पे लगी होती है.
हाँ, नहीं, राउटर से कंप्यूटर पे कंसोल केबल लगती है.
अच्छा, फिर मतलब वो जैक से जो राउटर पे आ रही होती है वो ईथरनेट केबल है.
जैक से
I think she's talking about that cable which we always get from the, when we buy the Wi-Fi routers and all, we always get a set of cables. That's the RJ45 which gets connected with the router to these computers.
She's talking about the cable which is connected on the NIC card.
Yeah, might be.
Okay, probably I may be getting confused, or
That is
I may be right.
that is
not wrong.
RJ45 only. That is RJ45
Yeah,
only.
it's an RJ45 only. Exactly.
Yeah. Okay.
Basically, we call it Ethernet and all.
All right.
Dual lanes.
Okay. So मैं यही बोल रहा था कि ईथरनेट केबल और RJ45 केबल दोनों एक ही होता है. ठीक है. ईथरनेट केबल हम कॉमनली बोलते हैं, ठीक है, बट उसको वो एक्चुअली उसका एक्चुअल टर्म RJ45 केबल होता है.
RJ45 is just a connector, right?
That is also true. That is also true. But we call it, again, as we call it as an Ethernet cable, we call it as an RJ45 cable also.
Okay.
Yeah. Now coming to our data link layer. Right. Now first of all let's go behind the history of connectivity. So I believe when I believe the computers, okay, I believe the computers were invented to do faster mathematical calculations. Okay, faster maths. Okay, and we achieved it. Obviously, computers were able to do faster mathematical calculations. We were able to even stop World War II with the help of computers. Right now, I would request everyone to please go on mute. Okay. Now, what happens is, as your technology started to develop or go beyond, we wanted two computers to start sharing their mathematical information with each other. Okay, so what we did, we created some mechanism where they could talk to each other. So we gave them some ports, we connected them through wires, and they started sharing information. How do they share information? Why do they share information? Let's ignore that or keep it aside. Let's just understand some history through a story. Right. Now, as again, more and more computers started to come up, we thought, let's have these computers share information with each other. So what we did, we started interconnecting these guys together. Right? So what happened was, as more and more computers started to come up, as more and more information wanted to be shared, we wanted more and more ports or interfaces or facility to connect different or multiple wires into one single computer. With just 4 computers, we can see that PC number 1, okay, needs 3 wires to connect to these 3 other PCs. Similarly, PC number 2 needs 3 wires, 3 and 4. Both these PCs need 3 wire to connect to all the other devices. Right? Just imagine if there are 1,000 devices, 10,000 devices. Right? We know computers started to evolve very quickly. With that, we could not afford, if there are, for example, if there are, just imagine if there are 100 computers in a room and you want 100 computers to talk to each other. On PC number 1, you should have 99 different ports. Was that feasible? No, that was not feasible. So what we did, we said, we invented or we created one device called as a hub. Okay, called as a hub. Hub was the first unintelligent device. Okay, why unintelligent? I'll tell you just now. Unintelligent device, but it had a useful purpose. The purpose was, if any information is sent by PC number 1, okay, what the hub will do is, hub will copy it and create duplicates of it. And send it to PC number 2, PC number 3, and PC number 4. So any PC sends any information, it is basically duplicated by hub and shared with all the other devices that is connected to the hub. So if I connect 2 more devices here, right, these devices will also receive any information that is shared by, for example, PC number 4. PC number 4 sends some information. This information is then sent to PC number 3, 5, 2, 1, and 6. Okay. This was going okay, perfectly fine. But then we said, we came up with a requirement that I do not want PC number 3 and PC number 4. I do not want them to send some information. I want to send information only to PC number 2. What can I do? Okay. So for that purpose, we created another device. That device was an intelligent device. Okay. Now, why did I call switch an intelligent device? The reason is that when I connect multiple devices to a particular switch, okay, switch is a networking device. We'll talk about switch in probably tomorrow's or day after tomorrow's class. But for now, just imagine, just understand switch is a networking device. Okay. With the help of a switch, if PC number 1 wants to send some information to PC number 2, all it needs to do is, it needs to add some information. It needs to provide some information, and that information is the address. Okay. The address of PC number 1 and PC number 2. So in computer networks or in computer terminology, we call this address as MAC address. Okay. All our PCs have an address, a unique address that is called as a MAC address. Where does this MAC address reside? We'll talk about that in later class. So PC number 1, all it needs to do is, it needs to give a source MAC address. Basically, what is a source? From where this information is originating. That is the source. So that would be PC number 1's MAC address. Destination MAC is going to be PC number 2's MAC address. And PC number 1 will send this information to the switch. Switch will read only this information and forward it to PC number 2. And hence, PC number 3 and PC number 4 will never receive this information. Okay, so switch was intelligent enough to forward your data according to the information you provided. Hub did not do that. Hub, what it did, whatever information came, it just copies it, creates multiple information, and sends it out to all the devices. That was what Hub used to do, and that is why it was called as an unintelligent device. It did perform what we wanted, but still it did it unintelligently. Switch does it in a better way. Now, with the invention of, or with the creation of switch, okay, what we could do is we can expand our network. We can expand our network to any length, meaning that I can connect multiple devices to a particular switch. For example, this is switch number 1. Okay, so these are different PCs connected to a switch. Okay, now let me assume that I am sitting in an huge college campus. Okay, obviously, when it is a huge college campus, one switch cannot be connected to all the devices in the college campus. So if I need all the PCs in the college campus to talk to each other, what I could do is I can connect multiple switches together and expand the network. Okay, so here there will be multiple PCs connected. This is switch number 2. Switch number 2 will be connected to switch number 3. And these PCs can then talk to each other. Okay. So all here, let's imagine PC number 1 is sitting here and PC number, for example, this is PC number 99. If PC number 1 wants to send some information to PC number 99, all it needs to do is write the source MAC address. That would be PC number 1's. Destination MAC address is going to be PC number 99, and it will forward it to switch number 1. Switch number 1 will forward it to switch number 2. Switch number 2 will forward it to switch number 3, and it will go to switch number 99. How does this happen? We'll talk. This will be our discussion on in tomorrow or day after tomorrow or in further classes, but not today. Okay, just understand the concept here. Now, let's imagine if there are many physics teachers or maths teacher, for example, you're talking maths. Okay, there are a lot of maths teacher in the college. Here you have a maths teacher. Here you have a maths teacher. Here you have a maths, again a maths teacher. This is a maths teacher, and this is a maths teacher. Right now, if PC number 1 math teacher wants to share question paper with all the other math teacher, what he is supposed to do? He will write his source MAC address and the destination MAC address of this guy. He'll send it. After that, he'll write the destination MAC address of this guy. He'll send it. After that, he'll write this and this guy and this guy. So one by one, he has to write these source MAC address and destination MAC address multiple times. It's a repeated work. Do I need that? No. For that purpose, okay, for that purpose, we created something called as a VLAN. We have heard of the word LAN, which is basically called as local area network. Right now, VLAN means virtual local area network. With the help of VLAN, okay, with the help of VLAN, this PC number 1 math professor, what he will do is he will say, all you people, all the math people you guys are maths teacher or professors. So whatever information I will send, it should be received only by the maths professor. not by any other professors. So with VLANs, what he could do is he would say all these math professors are part of one single VLAN network. For example, that VLAN number is that VLAN name. For example, that VLAN name is maths. So whatever information he sends into the maths VLAN, it will be received only by the maths professors and by no one else. If there is a physics teacher sitting here, he will not receive this information. It will be received the information will be received only by the maths professor and not by the physics professor. This was the use of VLANs. Okay. Now, as I was saying, these VLANs, these MAC addresses, how these switches or how your PC or a mobile phone sends information through MAC addresses is what we see in your data link layer or your layer 2. VLANs could be understood like your WhatsApp group. You have a WhatsApp group number 1, WhatsApp group number 2. So any information that is sent by inside WhatsApp number 1 could be heard only by the people who are part of WhatsApp number 1 group. WhatsApp number 2 group can talk to each other, but these two groups, WhatsApp number 1 group and WhatsApp number 2 group, cannot talk to each other directly. That is how WhatsApp has created the application. Similarly, VLANs also work the same way. A person or a user in one VLAN cannot talk to another person in the VLAN. All this, how is this done? That is the study in your data link layer. Okay. Now, if you guys have ever been into a server room, okay, you would see that usually in a server room, what is done usually is that all these cables are part of one single VLAN to avoid confusion. Okay, they are all part of a single VLAN. These guys can be part of single VLAN. These guys may be a part of single VLAN, but these wires may go to different users who are sitting somewhere. But eventually, they all will be connected via this switch, and all these switch ports will be part of one single VLAN. For example, VLAN number 10 here, VLAN number 20, VLAN number 30. Right. So this is how basically your two devices are connected using a switch. Any question on your data link layer? Anything?
So जो multiple switches लग गए तो multiple switches के भी MAC addresses नहीं होंगे?
होंगे ना.
जैसे मैथ्स आपने कंप्यूटर 1 जहाँ लिखा है उसके पास सोर्स और डेस्टिनेशन एड्रेस है दूसरे कंप्यूटर का, तो स्विचेस का भी होगा ना?
स्विचेस का भी होगा, बिल्कुल होगा. पर स्विच कभी भी अपना मैक एड्रेस जो है, अपना मैक एड्रेस सिर्फ अपने नेबरिंग स्विच के साथ ही शेयर करता है. ठीक है, सिर्फ एक दूसरे के साथ. सिस्को के हिसाब से, सिस्को डिस्कवरी के लिए, बस एक दूसरे के बारे में जानने के लिए कि मैं कौन से डिवाइस के साथ कनेक्टेड हूं और मेरा कौन सा इंटरफेस दूसरे डिवाइस के इंटरफेस के साथ कनेक्टेड है. स्विच का मैक एड्रेस अभी तक मैंने जहां भी देखा है सिर्फ और सिर्फ स्पैनिंग ट्री प्रोटोकॉल में काम आता है. डेटा फॉरवर्डिंग में स्विच का मैक एड्रेस काम नहीं आता है. वो हमेशा एंड यूजर का मैक एड्रेस ही काम आता है. अगर स्विच कोई डेटा क्रिएट कर रहा है, अगर स्विच कोई डेटा क्रिएट कर रहा है तभी स्विच का मैक एड्रेस काम आएगा. अगर स्विच डेटा क्रिएट नहीं कर रहा है, स्विच सिर्फ वो डेटा फॉरवर्ड कर रहा है, तो स्विच का मैक एड्रेस काम नहीं आता.
स्विच भी डेटा क्रिएट कर सकता है? मतलब क्या डेटा क्रिएट मतलब?
स्पैनिंग ट्री के डेटा होते हैं. स्विच स्पैनिंग ट्री का डेटा क्रिएट कर रहा है. कोई प्रोटोकॉल चल रहा है, ठीक है, वो डेटा क्रिएट कर सकता है. HSRP एक डेटा है, वो डेटा क्रिएट कर सकता है. तो उसमें स्विच के मैक एड्रेसेस लगेंगे. इशवाक, प्लीज गो ऑन म्यूट. तो
so it means that switch is like behaving there a bridge.
Yes, switch behaves like a bridge.
Okay, thanks, sir.
Okay.
I got your point.
Switch behaves like a bridge. It only helps to pass on the
Pass that.
Okay, but if, as someone had asked, switches have MAC addresses, if switch is generating a traffic, that time switch will have a MAC, that data will have a MAC address of this switch. Otherwise, the data will not be of the switch, it will be of the originator of that data. So here in our scenario, when PC1 was creating this question paper, so the question paper will have the MAC address of PC number 1. Switch 1 will never add his MAC address to this data. How switches forward traffic, we'll talk about that in next class. Any other question?
Sir, what will be the destination MAC address in case of VLAN? Just like WhatsApp group, no? So what is the destination MAC address?
Okay, since you have asked me, I'll let me, I hope you know how VLANs work. I hope you know in VLAN, in a same VLAN, there are different devices together, right? So switch keeps a note of the interfaces which are part of the VLANs. Switch keeps a note of the interfaces. Okay, Itashri, let's talk about VLAN tomorrow, because if I start talking about VLAN, it will get confusing right now.
I think this is becoming a bit confusing right now.
Right. So yeah, this will become confusing. I do not want to talk about something that is not part of today's class. Okay. So we'll talk about this tomorrow. Or let me finish this session today. I'll take questions afterwards.
Hi, sir.
Yeah.
I have a question, sir. Hub and unmanageable switch is same. Is it same?
Can you repeat your question? Sorry. Can you repeat your question?
Sir, the hub and unmanageable switch, those are same?
Yes, you can think. Unmanageable, not same, not exactly same. Repeaters and hubs are same.
Okay.
Unmanageable switches are something that you cannot configure. It's all plug and play. Okay,
Yeah,
plug and play where you cannot do anything. Okay, it's all configured. You just need to connect devices and the switch will start working. It still works. Okay, repeater and hubs are same. Unmanageable switches are not exactly hubs. All right. Now moving on to the layer 3. Now, as I was saying, in our layer 2, right? These are, as I was saying, these are small VLANs. All your maths teachers are part of a single VLAN network, right? Before VLAN, I said LAN, local area network. Again, to understand local area network, you can say that, okay, you can say, I am living in Pune. Okay, I live in Pune and I live in some area. Okay, and I'm living in a society. So in my society, all the people are part of a same network provided by Airtel. So Airtel himself has created a local area of networks. Okay, that is what you call it as LAN, local area of networks. So in my society, all the residents are connected together, right, in by some switch. So all of us are part of a small network, which is called as a LAN or local area network, right? Inside this local area network, we can create VLANs that I gave a small explanation about just some time before. Right? Now, if I want, obviously, in
Sir, I have a
Pune,
question there.
yeah.
For what purpose we are creating VLAN?
So that
What it gives us?
shall I take this question after the class? I'll answer this
Okay.
question after the class. Okay, let me
Okay,
finish
sir.
this.
Sure,
Right.
sir.
Now, obviously, I am part of some LAN, right? Obviously, in Pune, there is not just my society. There are lakhs of societies in Pune. All of them will be forming small LANs. I'm able to talk to people inside my LAN and people who are not part of my LAN also. I'm able to talk to them. So if I want, this is, for example, I live in an area called as Wakad. Okay. And this is an airport area. Okay. So I can send message to a person living in the airport area. He can also send me message and I'm not living in the airport area. Okay. So this diagram exactly shows what is that. So if you want two different LAN networks to talk to each other, right? If you want two different LAN networks to talk to each other, you need something called as a router, a device, which is called as a router. In our data link layer, we spoke about a device called as switch. In layer 3, there is a device which helps multiple LANs to connect to each other. That device is called as a router. With routers, you can connect multiple LANs which are geographically located at different parts of the country or city or even small space. Now, this network layer, router basically can run at network layer, basically helps helps with the information at the network layer. What are those information? I'll let you know now. So in order to understand our network layer, let's just go to our map. Okay, let's go to our map. Now, if you type, okay, if you want to go, for example, if you want to go from Coimbatore to Chennai, you want to go to from Coimbatore, this is your source and Chennai is your destination. Okay, or Bangalore is your destination, whatever. When you do that, obviously Google Map shows you the best path, correct, or the best road. So here the best road would be via Erode, Salem, Tiruvannamalai, Mahabalipuram and Chennai. This is one way, right? You can go like this also, in an indirect way also. So to reach Chennai, you have different ways. And right now I'm only including road travel. I'm not including train travel. I'm not including flight travels. I'm just including road travels for now. So you have different ways to reach from Coimbatore to Chennai. Now, in computer networks, if you want to understand or computer networks or network layer, in your network layer, these roads are called as IP or Internet Protocol. Internet Protocol. These roads are your IP. Basically, roads are already built. Roads are already built or already present. Similarly, IP in computer or your networking, these roads, right? Your information or whatever data is being exchanged between you and me is taking some road, and that road in computer network is called as IP, Internet Protocol. You have two different types of roads in computer network. One is called as an IPv4 and the other is called as an IPv6. So you have two types of roads. In our human world, you have different, you have a lot of roads. You have 2-lane road, 3-lane road, you have a kacha road, you have a cement road, you have a mud road, you have a tar road. There are different types of roads. But in computer networks, you just have two types of roads. One is IPv4, the other is IPv6.
So it's totally depend upon computer which IP follow they want to follow. चाहे वो IPv4 भी follow कर सकता है, IPv6 भी follow कर सकते हैं. अगर मुझे आपको डेटा भेजना है तो मेरे कंप्यूटर डिसाइड कर लेगा कि मैं IPv6 पे काम करूंगा. मैं IPv6 follow करूंगा रोड मैप.
Yes, it can decide. कर सकता है वो. IPv4 करेगा, IPv6 करेगा, वो हम नहीं देख सकते.
और IP एड्रेस फिर क्या होता है?
Sorry for the
IP होता है तो.
हाँ, मैं बताता हूँ.
Like Yeah, this is Sarvin. Can we keep in
Is
English?
anyone speaking?
Yeah, this is Sarvin.
Yeah.
Can we speak in? I mean, can we keep in English, because some of the questions, right, not able to understand when we are speaking Hindi, right? So not able to get you people.
Yeah, sure. So what she asked is, any computer, okay, we cannot control what kind of road does the computer take or your computer data takes. It can be an IPv4 road or an IPv6 road. Okay, and if until it, and it also depends on the application you're using. If your application requires an IPv6, it will use an IPv6 road. Okay, if I show you now, my computer would be sending data to you using an IPv4 protocol or network or road in computer networks term. Okay, I'll show you that in some time. Right. Now, if road is IPv4 and IPv6, okay, you have different vehicles who use these roads, right? So you have different roads. Sorry, you have different vehicles, right?
IP stands for Internet Protocol.
Yeah, Internet Protocol. So we, on your road, we drive vehicles, and there are different vehicles. You have bicycle, you have bikes. So from Coimbatore to Chennai, you can go via bus. You can from via road, you can use bus. You can use car, you can use bike. If you want to go on foot, you can also go. It's up to you. Okay. So if vehicles are, if buses and all those are vehicles, in computer networks, you call them as routing protocols. Okay. Using these routing protocols, you send data. Using these routing protocols, you send data. And there are different types of routing protocols. You have OSPF, EIGRP, right? Then you have BGP, you have ISIS, intermediary system to intermediary system. There are a lot of different routing protocols. Now, using these vehicles, we passengers are going from one place to another place, right? So inside your vehicles, you have passengers. And in computer networks, these passengers are nothing but your data. So your OSPF, EIGRP, BGP, ISAS, these vehicles are basically carrying your data using IPv4 or IPv6 roads. Right. Now, you on your roads, you have different lanes. You have a 2-lane road, right? You have a 4-lane road, you have a 6-lane road, you have a 8-lane road. Now you have 10-lane roads also, right? So what is happening? As the width of your road increases, you can go faster. On a 2-lane road, if there are 100 vehicles going, you will be going very slowly. And if those 100 vehicles are going on a 10-lane road, you can go faster. Why? Because your speed increases. You have way. You can go between vehicles. You can go faster. Your speed increases. So in comparison to our lanes in your computer networks, we call that as bandwidth. Right? So you would have heard, I have a 200 Mbps bandwidth. I have a 1000 Mbps bandwidth. I have 10 gigabit bandwidth. That basically means the speed of your, basically the speed at which your data can go, right? So that is bandwidth. Now, these locations, right? So you have Coimbatore, Erode, Salem, Tiruvannamalai, Kanjipuram, Mahabalipuram, and Chennai. Right? These locations. So what I do is, or when I open Google Map, right? It says, go straight using this road till next 5 kilometers, right? The Google lady, it gives me some directions, right? Go straight for 1.5 kilometer, then turn right, take this road, take that road, etc. Right? Now Similarly, when I from Coimbatore, when I go to E Road, when I reach E Road, right? The moment I'm going to enter E Road, right? The Google is going to tell me keep going straight and use this exit road to go towards Chennai. Correct. Then after I exit E Road, I come to Salem. The moment I come to Salem, the Google tells me use this exit road to go to Chennai. Right. Now in computer networks, if I want to compare them, these locations are nothing but your routers, the devices, which basically are helping the IP to carry these data or helping the vehicles to send these passengers through them.
सर exit road क्या होता है? Sorry.
आप कहाँ के रहने वाले हो? Where are you from?
So Delhi.
Delhi. So if you want to go to Jaipur, how will you go? You will take the Gurgaon Jaipur exit, correct? So गुवाहाटी बोल रहा हूँ, गुड़गांव से जयपुर जाने के लिए वो हाईवे है, गुड़गांव जयपुर हाईवे, तो वो एग्जिट है आपके लिए. वहां से आप एग्जिट करोगे, गुड़गांव से आप एग्जिट करोगे, आप बाहर निकलोगे और यूल go out of Gurgaon and then you'll keep going towards Jaipur. Similarly, on your routers, when any traffic comes, on a router, when any traffic comes, it makes those decisions of how to forward the data. How it makes the decision, that's for some other class. But these locations are just like your routers in computer network. Sorry. Routers are just like your locations. Okay. Forget Google Map. When there was no mobile, what you used to do? You'll go to E Road, you'll ask someone, right? Brother, how do I go to Salem? How do I go to Chennai? He will say, take straight, go there. That's the exit, right? This is how he tells. So each of your locations are the same way. Your data comes, hits the router, it asks, how do I reach Chennai? The router makes some calculations of how should it forward this data. And after making that calculation, it sends it out of its exit interface. What is interface? We'll talk about that. Interface is just like your ports, right?
So, okay, if someone is asking me, tell me your IP address, that means it is Internet Protocol address.
Correct.
Okay.
So all this information, right? If the data is using an IPv4 or IPv6, what kind of vehicle is it? An OSPF, EIGRP, ISIS, what kind of data is it carrying? What kind of bandwidth is it using? And all this information is processed at your network layer, at your third layer or your network layer. Okay. As I was saying,
does the bandwidth will depend upon the IPv4 or IPv6?
No. Bandwidth is never related to your IPv4 or IPv6.
Okay, so these are different things, huh?
Yeah. I'm just trying to compare these two through real-time analogies.
Right.
These are not the exact match. They're not exact match, but just for visual concept or understanding sake, I'm trying to compare them.
Okay.
Now coming to the next layer, layer 4.
Before Laksh, I would ask a question here.
Hello, sir. I have a question.
Hold on. Rohan, please ask first. Ifshak, after let him finish first. Yeah. Rohan,
as we know that you said that there are two types of internet protocol, that is IPv4 and IPv6. Okay. But here, if I come up with a question stating that, can you just explain me or can you just differentiate between those two protocols? So how would you come up with an answer for that?
Shall I answer that later?
Okay, then I have a second question as well, which you can answer me later. That is about the routing protocols as well.
Okay, no
Will
problem.
that be fine?
Yeah.
Okay.
The reason I'm not answering right
I
now
understand.
because
It will
that's not
interrupt.
the part of our discussion or today's session. Okay.
Okay, got it.
Yeah. Now, layer
Okay,
4.
sir, I have a question. Maybe
Yeah, sorry, Ishwak. Yeah, sorry.
So
Yeah,
what
please
is
go
the
on.
main difference between IPv4 and IPv6? If there is IPv4, we are working on it, then why IPv6 has been big?
In short, let me answer your question. In short, I'm not going to detail. IPv4 is 32 bits.
Okay.
Okay, IPv4 is 128 bits. With 32 bits, you have around, for I think only some 100 crore or 200 crore IP addresses, which
Yes, sir.
okay, with 128 bits, even you cannot count how many kind of IP addresses you can have.
In IPv4.
In IPv6, IPv6 is 128 bits. Okay, with 32 bits address, your IPv4 address is already gone. Okay,
But
IPv4 address is already gone.
in present scenario, we are using IPv4 as well.
IPv4, yes, in present we use IPv4 and IPv6 both. How? We'll talk about that in some other class, not today.
Okay.
Yeah. Now, in front of you, you can see some screenshots from WhatsApp messages. Right? So you see, when you send some message to your friend, you can see this send. It is sent. It is received by your friend. Your friend has read that message. You can see all these messages. Second example, if you send a message and it does not get delivered, you will see an error message, not delivered, right? Sometimes if you are opening WhatsApp messages after a very long time, okay, you will see this message, waiting for this message. This may take a while. Ask the sender to send it again, sometime like this. And if you're trying to download some image or video file, if it fails, you will see this kind of message. How does your phone know? How does your phone know that your friend has the message has been sent? Your friend has received the message. He has read the message. The message did not get delivered. The message is taking too much time, or the download failed. How does your phone know? Right? The reason is, inside our phone or inside any networking device, you have a layer called as transport layer. You have a transport layer which basically tells the other device that the message that you sent or the information that you sent has not been received by me completely. Okay, that means if you have a phone, I am sending some message. Okay, I sent a message, for example, hi, right? Or for example, this is me. Okay, and this is my father. So if I say hi to my father, and if he does not listen, if he does not reply back with a hi, right, that means he did not hear me. I will send, or I will say hi to him once again, and I will say it louder so that he can hear me. And after that, he'll again say me, hi, son. Correct? So this hi, son is basically an acknowledgement. It's an acknowledgement. Right? So my father is acknowledging my hi. Similarly, all these messages are basically an acknowledgement that is sent by the other device. These are an acknowledgement that is sent by the other device. And because the other device is sending an acknowledgement, you are able to see these messages. If the other device does not send an acknowledgement, or in this example, first one here, when you send a message, and if it does not even reach your friend's phone, here you will see some kind of a clock or timer, something like this. Right? That means it's not even sent there. How does your phone know? How does your phone know? Because your WhatsApp server is sending this. Your WhatsApp server is sending this, that it is not sent till now. So all this acknowledgement, first of all, why do we need an acknowledgement? If I am saying, guys, can you hear me? You guys will say, yes, we can hear you. right? I need that acknowledgement. If I do not get an acknowledgement from you guys, I will keep on asking the same question. Guys, can you hear me? Guys, can you hear me? Right? That is why we need an acknowledgement. Without an acknowledgement, data transfer cannot happen. Right? Now, let me open your Netflix server. Okay, when I do a netflix.com, right, something happened. This, whatever you see on the screen, is basically an acknowledgement for me. When I did a netflix.com, it gave me something back on the browser, right? With that, I know my internet is working. That is a kind of an acknowledgement. If it did not work, it would have shown me a 404 error, right? Or oops, something is wrong, something like that. That means my information did not reach the Netflix server. So whenever there is some communication, I need an acknowledgement. When I need an acknowledgement, when I get an acknowledgement, then only I can have proper transmission of data. Without that, proper transmission is not possible. Right. Now, in your TCP layer, or it's not TCP layer, sorry, transport layer, you have two types of protocols. One is your TCP, transmission control protocol, or transport control protocol. And the second is UDP, user datagram protocol. User datagram protocol. Now, why do we need these two protocols? I am pretty sure you guys watch IPL, right? And it's all live, right? On I think on Geo TV, you guys watch IPL, right? So what is happening, right? The match is being telecasted or broadcasted, right? And it is broadcasted to all over. It is broadcasted all over India, or even whoever is. It is basically broadcasted to the Geo server. Geo server is basically broadcasting everywhere, right? Now it is broadcasting live. Now what happens? Sometimes you would have seen a bowler is about to throw the ball, and suddenly your internet freezes for 5 seconds. Right? Internet basically freezes for 5 seconds. And then what happens? After 5 seconds, the live is not going to go back. It's going to continue after that 5 seconds. Correct? So you have missed those 5 seconds, where in those 5 seconds, the batsman was out. Right? And you cannot rewind it. You can only watch the replay. You cannot rewind the live. You can only watch the replay. If you want to watch the replay, you have to watch the highlights, right? So what is happening? All your live streaming, even this live streaming, what I'm doing with you guys, is happening over UDP. Why? In UDP or in your live streaming, there is no acknowledgement. There is no acknowledgement. If I cannot hear your voice, or you cannot hear my voice, you will miss it. Right? You will say, sir, we cannot hear your voice, and I will repeat it. UDP does not give us acknowledgement, wherein TCP gives us acknowledgement. So this example that I showed you, when I did a netflix.com, right? When I did a netflix.com, it showed me some result. This is happening over TCP. So this is reliability. If I am sending some information, I am getting a response. This is called as acknowledgement as well as reliability. When I hear an acknowledgement, I know whatever message I sent has been received, and he's sending me a response. This is reliability and acknowledgement. In UDP, this is not going to happen, and I can show you that real time. So let me open my Wireshark. And whatever information is being sent out of my laptop's Wi-Fi adapter, I'll show you. So all this information currently is being sent out of my laptop. Okay. And if you can see, if I open one of the packets here, you will see UDP, user datagram protocol. So I am live with you guys, right? Whatever information that I'm sending is live and it is happening over UDP. Okay. And if I'm watching some movie over Netflix and suppose I stop the Zoom call, and I start watching some movie on Netflix, it will show me TCP. Why? Because it's not live. I am asking some information from the Netflix server. The Netflix server is sending back that information. So if I click on some movie, the moment I click on a movie, my laptop is sending the information to the Netflix server saying I clicked on this movie. The Netflix server will then start showing me that movie, sending me data of that movie. This is acknowledgement and reliability. So all your live streaming happens at UDP where you do not have acknowledgements. At your TCP level, where all your bank transactions, your web browsing, all that happens at TCP layer. And all this acknowledgement that you see is because of TCP protocol at your transport layer.
सर आपने
Any
जो
question?
यूडीपी दिखाया था वो क्या था? ठीक है, मैं समझ गई यूडीपी एक्नॉलेज नहीं करता, बट और क्या एग्जांपल हो सकते हैं, और वो यूडीपी क्या दिखाया था आपने?
This UDP is the UDP connection with the Zoom server. My data transfer is happening over UDP. Got this? मेरा जो भी डेटा ट्रांसफर अभी चल रहा है वो यूडीपी पे चल रहा है, वो टीसीपी पे नहीं चल रहा है. अगर मैं कोई मूवी देखता हूं या फिर मैं कोई बैंक ट्रांजैक्शन करता हूं तब यहां पे मुझे टीसीपी दिखाई देगा, क्योंकि
तो हमने भी तो जूम को कहा ना कि हमें जूम मीटिंग करनी है, तो उसने हमारे पे एक्नॉलेज करा, आपको प्लेटफॉर्म दिया मीटिंग कंडक्ट करने का, मीटिंग क्रिएट
हाँ
कर.
वो इनिशियल सब अब हर चीज यूडीपी टीसीपी नहीं हो सकता ना. यहाँ पे देखो कितनी सारी इंफॉर्मेशन जा रही है. ठीक है, यहाँ पे एक टीसीपी गया था, अब भी मैंने जस्ट देखा एक टीसीपी गया. ये कुछ एक टीसीपी गया यहाँ से, ये टीएलएस है, यहाँ पे कुछ एक टीसीपी था,
हाँ देखा था मैंने.
टीसीपी. तो मैं वही बता रहा हूँ, हर जरूरी नहीं है कि हर इंफॉर्मेशन यूडीपी हो, हर इंफॉर्मेशन यूडीपी होना जरूरी नहीं है. बट करंटली मैं जो भी बात कर रहा हूं, मैं जो भी इंफॉर्मेशन भेज रहा हूं वो यूडीपी है. ऑब्वियसली मेरे लैपटॉप से बहुत सारे इंफॉर्मेशन बैकग्राउंड में चल रहे हैं, प्रोबेबली वो टीसीपी चला रहे हो.
सर ये
ठीक
कौन
है,
सी एप्लीकेशन है ये?
ये वायर शार्क है.
क्या
हाँ,
क्या यूज है इसका?
so Wireshark helps in real time capturing of data.
Okay.
Okay.
We have to
So
install this.
it's open source, you can download it through the Google.
Okay.
So when I clicked on Zoom, when I asked Zoom for to let me join some meeting, that is only TCP. After that, whatever information is being shared is on UDP.
Sir, the chat we are doing right now, that is TCP or UDP?
That is based on
This
the
chat.
application. See, Zoom, the right now this or whatever I am telling you is all UDP that you can see. The chat is basically the feature of the application. Okay, it's the feature of the application. I am not completely sure. Okay, it should be TCP. It should be TCP because when you are sending this information, the Zoom application, it's not even it is TCP. You are typing. Okay, the Zoom application is taking your message, storing it in this chat box, and everyone can see it. If it was UDP, okay, it would have just vanished.
Okay, sir.
Okay, so whatever information where you can see the acknowledgement coming back in the chat box, whatever someone is typing, I can see it. It's TCP. I can see it. It is TCP. In UDP, I would not have even seen it. It would have come, it would have gone. Any question with this?
Sir, what is three-way handshake and four-way handshake? I mean, connection establishment and termination
That's a
in
part of,
TCP.
yeah, that's a part of TCP initiation or connectivity when two devices are about to start TCP connectivity between themselves. So when I did Netflix.com, my laptop and the Netflix server would have created a TCP connection starting with three-way handshake, which is not the discussion for today. I'll explain that when it comes. Right. Now coming to our last layer, application layer. Okay. As I said, in your TCP IP layer, your layer 5, 6, and 7 are grouped together and called as application layer. Correct. Now, what happens in the application layer? What do we study in the application layer? As network engineer, we will never deal with application layer. Okay. But what happens in the background of this application layer, we'll work with that. So what happens? Now, when I did here, let me close this window. Okay. Let me do netflix.com again. Netflix.com. Okay. So you see, this is buffering. This buffers, it takes some time to load, right? It takes some time to load and it gives me this UI or GUI of the Netflix, correct? Now what happens? In application layer, when I type netflix.com, obviously netflix.com, okay, .com is a human readable form. Human readable form. Computers or any networking devices do not understand words. They do not understand ASCII format. I hope you understand what is ASCII. ASCII is basically the binary equivalent for binary numbers. Okay. For example, if you are writing A, letter A, right? Using the ASCII conversion, A letter will be converted into a binary format and the computer will be able to understand this letter. Okay. So Netflix, as I was saying, netflix.com is a human readable format. And computers cannot understand this netflix.com. They need some numbers or they need some address. This is basically the address. We know that this is called as universal resource locator, right? URL. Computers cannot understand URL. They can understand only IP addresses, which basically is in your network layer. IP addresses. They can understand only IP addresses. So to convert your URL into an IP address, you need to go to something called as DNS, domain name server. Okay. Which basically converts your URL to your IP address, to the relevant IP address. Google.com. When I do a Google.com, Google.com has a fixed IP address. Okay, it has a particular IP address, right? So basically, my computer goes to the DNS, domain name server, says that, do you know what is the IP address of netflix.com? The DNS server gives my computer the IP address of the netflix.com. And after my computer gets the IP address of the netflix.com, it initiates a TCP connection, which we saw here. Okay, how it initiates, what happens in the initiation, that is after when we are talking about TCP in detail, we'll talk about that. So now what happens?
Lux,
Yeah.
just wanting you to know that I am very much new to this IT branch. I was working as a mechanical engineer, but now I'm transforming my career into IT. Just wanting to let you know.
Yeah, don't worry. If you do not understand anything right now, don't worry.
So,
in the further classes, you will.
For example,
These things will get clear.
For example,
Don't
you
worry.
assume that as ASCII will be understood by everyone. So I don't know what is ASCII is.
Don't worry, no worries, no worries. Okay, just understand the concept. Do not get inside the terminology for today's class. Okay. My intention for today's class is just to let you know how computer networks is surrounding us in real time.
Okay.
Okay, we are surrounded by computer networks. So anyway, after my computer gets the IP address, it initiates a TCP connection with the Netflix server. Why? So that whatever information I ask the Netflix server, I get a response, an acknowledgement, right? When I get an acknowledgement, then only I can create this GUI. Otherwise, my computer will not be able to create this GUI, right? What is happening? My computer is sending or asking information from the Netflix server, and the Netflix server is sending back the data. And with that data, my computer is able to create this web page. That is what happens at your application layer. Application layer takes the help of the below layers. Your transport layer, see here, this TCP. TCP is your layer 4. Okay, and this request is being sent, response is being received, and after that, all your web pages, all these web pages are getting loaded. Okay, so my data, the data that I am sending from my computer to the Netflix server is going through. If you see, let's just imagine this as your Netflix server's data, right? There are so many information that is being created, right? At the application layer, at the layer 4, at the layer 3, at the layer 2. So at your application layer, whatever you see on the screen is running at the application layer. But in the background, your layer 4 is also working. Your layer 3 is also working. Your layer 2 is also working. Your layer 1 is also working. So coming back to our first discussion, your data, your higher layer data is encapsulated by your lower layer data, right? So this is why I started with the encapsulation and decapsulation part. At your layer 5, whatever you do at layer 5 or that layer 5 at the TCP layer or layer 7 at your OSI layer, everything gets encapsulated or enveloped inside your layer, lower layer. That is what we can see in real time. Here your layer 4 is inside your layer 3, IPv4. IPv4 is inside your layer 2. My layer 2 information is then on the wire. 1101 bytes on my wire. Wire basically is the wireless adapter here. Right. So now all this discussion, whatever we did, is part of computer networks. And this is how your two devices are able to talk to each other. Right. And this study of computer networks in detail is what we will be learning in our course of CCNA, which basically is Cisco Certified Network Associate.
So what will be the timings for this batch?
9 to 10, 10:30, depends on the topic. 9 p.m. to 10:30. So,
sir, how is long going on this course? Like 1 month, 2 months?
If we are going
I'm not
every
sure.
day.
I'm not sure. The way
Okay.
I would say 3 months.
Okay.
I will say I will say 3 months. Okay. So anyway, so as I was saying, This is what we will be studying in our course of CCNA, Cisco Certified Network Associate. Okay.
What a ASCII keys? What a ASCII keys you are saying?
Yeah, I'll come to that in some time. Give me a minute. Okay. So Cisco Certified Network Associate. This certification is conducted by the company Cisco. Okay, which basically is a product company. Product company meaning it creates its own products, networking products like routers or switches or Wi-Fi modems or servers. So Cisco is a product company which creates network products, right? And after CCNA, you have the second level, which is called as CCNP, Cisco Certified Network Professional. Okay, and there is a specialist also, CCNP specialist, which basically is your CCI return. Okay, which basically is your CCI return, and then you finally have your CCI lab. Okay, so this course we are only going to go through CCNA, Cisco Certified Network Associate, and I think the exam fee is, if I'm not wrong, it's around $200. If I'm not wrong, it's around $200 or $300, something like that.
Yes, sir. It's $300.
It's $300.
Yeah, so it's around $300. Okay.
So do we have lab for CCNA?
Yes, we do have labs for CCNA.
Sir, is this session recorded?
Yes, it is recorded.
Where can I find it after we're done?
You can find these recordings if your ID is created. Once you enroll, your IDs would be created. Okay.
Yeah,
and
I'm enrolled
yeah,
in the Networkings and I have an account.
yeah. So you can go to learn.networkings.com. There on your dashboard. Yeah. On your dashboard, you will see your courses with these recordings.
After this class, how many time it take for uploaded?
Around 2 or 3 hours.
Okay.
Okay, so by tomorrow morning I can expect to find it.
Yes. Yes.
Okay, thank you, sir.
Okay.
Hello, sir.
Just a little note, sir. I'm not from India, so if we can like speak English all of the time so that I can understand everything.
This is the English class only. Sometimes, people ask questions in our Hindi or any other of their local language. So I'll repeat their question and I'll repeat my answer as well.
Okay, sir. Thank you.
Laksh,
yeah.
As you said that this is for only CCNA, so does that mean that you are the only one who will be taking for CCNA and we have another guy who will be coming up with CCNP? Is that so?
I am taking CCNA for now. Okay, I am not taking CCNP for you people right now. Okay, so you should speak to the networking's management. Yes.
Okay.
Give me a minute. Let me hold on. Let me. Okay, guys. Yes.
Hello.
Tell me. Yeah.
I have the very general questions. Is like I'm doing CCNA now, okay, and I have enrolled another course as well, CCNP. So what do you think? Like I have been not good command in networking as well, but like I want to do like like 6 months getting at both of them, like CCN or CCNP. So like how much time I to give to the for the CCNA certificate for the like how much study every day I do, like in general.
Okay. Let me tell you one thing very clearly. If you go through the books, okay, the CCNA books, okay, I will share the PDF with you guys today or tomorrow or day after tomorrow. So I would request you guys to go through the books. Okay. The reason is the books have more details, right? And from my experience, I would say reading the book or the one chapter every day, you should be, and if you practice by your own, you should be able, for CCNA, you should be prepared in just 3 months. Okay.
Just for and
CCNP.
like how
Yeah, go on.
How is important for the CCNA certificate? Is it like is if it's necessary for to go towards the certificate, or it's fine for we go with the CCNP and then go for the CCNP certificate like Encore or maybe NRC?
See, the CCNP is kind of a bit tough. Okay.
Yeah, that's I see a lot of video on YouTube.
Yeah.
So
The reason CCNP is tough is because there are two types of exams in it. As I was saying, one is professional, the other is specialist. Okay. Professional is easy. Specialist is a bit tough because it's CCI written exam. You can write, you can even avoid writing CCN exam and directly write CCNP. That's okay. But the amount of effort that you will need to put into the CCNP specialist or professional exam would be more. The reason is that whoever is teaching you CCNP, okay, he is teaching with the mindset that you already know about the CCNA. You are aware of the routing protocols, you're aware of what is a switch, you're aware of how things work inside a network already. So anyone who is teaching you CCNP is not going to go over the basics. So in order for you to understand CCNP better, my suggestion would be to go through the CCNA books or videos or course first, rather than jumping to CCNP directly.
I have a question. Will you be following CCNA curriculum or your own curriculum?
CCNA curriculum.
Okay.
Okay, Laksh, as you said, you have a good amount of experience in the companies and all. Tell me just one thing. Like as of now, we are going through with the CCNA classes, right? So once the classes get completed, we know the networkings will be providing us the certificates. That's fine. But as per your experience, if we are not giving the CCNA exam, which will costing us like 30,000 approx as per INR, so is it worth of like it's not worth, right? If we are not giving the exam, which is internationally, I would say applicable.
It is still worth. See, any exam, any certificates. Okay. There are two reasons. Okay. It is worth outside. Okay. It is less of a worth in India. If you are CCNP professional, or if you're a CCNP specialist, that has a lot of worth. If you're a CCI, that has a lot of worth. But in India, CCNA has less of a worth. The reason is there are a lot of people who are CCNA certified. There are a lot of people who are there are a lot of people who are CCNA certified. Okay, just because their company asked, or just because their customer asked. Okay, but if you go to any product company like Cisco, Juniper, or HP, or IBM, they know the worth of CCNA. But if you go to any service-based companies, okay, Infosys, TCS, Cognizant, they do not know the value of CCNA. Okay, they may know the value of, they may not even know the value of CCNP, but they may know the value of CCI. But if you go to product companies, they even value your CCNA certificates. Right. Now to answer your question, if it is worth, yes, it is worth. The reason is many people do not even attempt CCNP certificates. Okay, they do not even attempt CCNP levels. Okay, so because they do not attempt CCNP, they do not even attempt CCNA. because they think CCNA no one is going to it's not
look
worth.
after.
Yeah, no one is going to look at it. So they even they do not even try attempting CCNA. Okay, and because CCNP is even higher, it needs more of an effort. They do not even attempt for CCNP. So basically, what happens then? You are under a loss. It's better to have a CCNA, even if you do not attempt CCNP. It's okay. At least you have a CCNA, right?
Yeah.
Then if since you guys if you are new in networking, if you are new in the career, okay, if you are new to this whole corporate world, it's better to have a CCNA at the earliest.
Yeah.
Okay, but as you move on, if you like me, if I a person like me who has 9 years of experience, right? If I just have CCNA, it's not going to work.
Yeah.
Right? I should have a CCNP or I should have a CCI certificate. If you're a fresher, if you are under 5 years of experience, you should have CCNA.
No, I was asking that I'm also having experience of 7 years and still working. So that's the reason I was saying. So overall, I think I should go ahead with CCNP, right?
You can go, yes, you should go with CCNP. There's no problem.
Yeah.
Yeah.
Hi, Laksh.
And Laksh, as of now, we are only going to have these type of questions, right? No questions related to what we just had the class, right?
I have
Sorry, I did not
questions to
understand your
ask.
question.
I'm saying that as of now, we all of us are asking questions to you. So the questions will be as of the courses and all, right? You're not going to answer the questions which are related to what we just studied half an hour ago. So that's what I was asking. I can leave, right? Because I have my office time is going.
Yeah.
Okay.
Yes.
So we can come up with questions tomorrow, right? Which I was having about
yeah,
the.
no problem.
Okay.
Yeah.
Thanks, Laksh.
Yeah, thank you.
Hi, Laksh.
Hold on. Let me go one by one. Everyone who wants to ask a question, please raise your hand so that I can come in an alphabetical order, because everyone is because everyone is interrupting each other. Okay. So yes, K Chandu, please ask your question.
Yes, hi, Laksh.
Yeah.
So I can assume that each and every network device have these layers present in their devices, right? I mean, these layers are not present somewhere else. I mean, they are included in their whatever hardware, right?
Yes.
Okay, all 7 layers are present in the network devices, right? Either it's maybe a router or a firewall or else computer. They have
Not
their own layer.
exactly all the 7 layers. Okay.
Okay.
All the 7 layers are present, but not all the layers are used.
Okay. I think you will explain this in detail in upcoming classes, right?
Yes.
Yeah. Okay. So basically, I was more confused about layers, so that's the reason I'm asking.
No problem.
Okay. Thank you.
Hesham Habash. Yes.
Yes, will this course be enough for the $300 exam? Or do you have to learn more from YouTube and stuff or books?
I guarantee this is enough.
Okay, so yeah, I just want I just want to take the exam and I want to get the certificate. So I had to make sure that we're gonna have the full knowledge for CCNA in this course.
Yeah. So see, my intention is not to help you clear the exam. My intention is to build a strong foundation. So be it the exam, be it an interview, or be it if you want to share your knowledge that you have gained from me, if you want to share that with others, your foundation, your network foundation is so strong that you can clear not just this exam, any other interview that is based on this CCNA level, you can clear that. That is my intention.
Okay, fine. And we're gonna get a certificate anyways from the course once we're done, right?
Correct.
All right. Thank you, sir.
No problem. Amit, yes.
Yes, sir. Sir, I just wanted to ask, there is some changes Cisco is going to they're going to make changes in CCNA topics curriculum. So like 10% topics will be changed. So is it possible to go through those topics in this course?
Mm, I'm not sure if those are the changes that. What are the changes?
In between of August, there is some changes on CCNA topics saw on their website. Yes, it is here.
Okay, these are still the old ones. The new ones have not been added.
Maybe they add in whatever the date they have shown in their website.
The about topics are to be included. The topics is to change at any time to reflect. Yeah, it's not yet changed for now. Yeah. So once it's changed, I'll take that.
Okay, sir.
Okay, Sharwin, yes.
Hi. So the port to be right?
Buddy, your voice is too low. I cannot hear you at all.
Can you hear me now? Now it's
You
better?
have to speak a bit louder.
Okay, now?
Yeah.
Okay, so the ports concept we have, right, in a transport layer.
Yeah,
Port numbers we have, right? TCP, UDP ports.
Yes.
Like, so you'll be covering later, or like you already covered part of transport, like
Everything is
I have
later.
not seen.
Today was just an introductory. Everything in detail is going to be in later classes.
Okay. The next question is the DNS we were speaking, right? So it's part of which layer? DNS, and which protocol it
DNS
works for that?
is a part of your application layer. It happens at application layer.
Okay.
Is
Does it
not
follows
part of
different
it's see it's not part of application layer, but
okay,
whatever is happening at DNS is because of the application layer. Your IP addresses are getting converted into your URL is getting converted into IP address is happening at the application layer, right? And your computer sends the message to the DNS server, right? All that is happening at layer 3, layer 2, layer 1. But since the DNS query is generated because your application layer queried it or sent that, converted it. That's why DNS also is called as is also said to be happening at layer 5.
Okay. What kind of protocol it follows? DNS server, right? Is there any specific protocol it follows for the conversion?
Conversion? No, there is no such protocol. It just has
like
a list of table, like for Google server, this is the IP address. For Netflix, this is the IP address. For this, for any other .com, this is the IP address. There's no such thing. Just keeps a note of it.
Only the mapping URL to IP,
Obviously,
correct?
the DNS server would have been programmed. Okay, how the programming is done, I'm not sure.
Okay. And the third question, right? The data link layer, when you were speaking, right? I was asking the LLC and MAC layer, correct? So you will be covering later, or
yes, yes.
Okay. Yeah, thanks. Yeah, that's it.
No problem. Kamran.
So how are we planning to go for the labs? Like, what will we be using for labs?
I'll use two softwares. One is Cisco Packet Tracer.
Okay.
Okay, and the other is GNS3.
So will you let us know how to get used to this?
Cisco Packet Tracer. Okay, and the other is GNS3. So yeah, I'll show you how to install Cisco Packet Tracer, and I'll share the YouTube links to install and configure GNS3 at a later point of time.
Okay. So one question which I was earlier discussing, like after this session, like you said that that question was could be better framed that router works in which layer. So what will be the now after this discussion, what should be the ideal question for this or ideal answer for that? That router works in which layer or switch works in which layer?
Okay, if someone asks me this question, I would say, see, switch works at two layer. It depends on what kind of what has that been programmed for. If it is a layer 2 switch, for example, if it is a layer 2 switch, it will understand only layer 2 information. If it is a layer 3 switch, it will understand layer 2 and layer 3 both.
Okay.
Beyond that, layer 4, layer 5, layer 6, it will not be able to understand.
Okay. And for router, what will you answer?
Router, I would say it works at physical layer, it works at data link layer, it works at network layer, it works at transport layer, and it works at layer 7 also, or layer 5. Reason, physical layer, obviously it's connected through wires, right? Data link layer, it understands MAC addresses. Layer 3, it understands IP addresses, right? Layer 4, it understands TCP protocols. Layer 7, it understands BGP.
Okay, then I think there are some confusion. Like I have read some documents saying router is a layer 4 device, and then it shouldn't be mentioned like that.
Router was created for the purpose of network layer. On network
yes.
Network layer has IP addresses, right? Router was created for that, right? So that is why it has been called as router is a layer 3 device since then. Okay. Yeah. Give me a minute. Let me mute. All right. Any other question, Kamran?
Yes, sir, I have.
No, I'm asking Kamran. No, right?
I think I should wait for the next classes. I think it will be a better description.
All right. Yeah, Amit.
Sir, I just want to ask, networkings also have labs for, so you, as you are going to teach in Cisco Packet Tracer and GNS, so could you demonstrate a networking labs as well so that we can perform labs?
Yes.
Okay, sir. Thank you.
I'll do that. Yeah.
Okay, sir.
All right. Any other question? Anyone?
Not a question, but it whatever terminology you're using, can you like give us a proper explanation for it? Because I don't belong from the IT background.
Okay. No worries. See, today's class was just an introductory class, just to give you a hint of what we will be learning. Okay. All the terminologies that I have mentioned. Okay. Do not worry about the terminologies. I hope the concept that I was trying to tell you, what happens.
Yes.
Today, my intention was just to show you these concepts and where are they used in real time.
Okay.
All these terminologies I will be telling in detail. I will be discussing these in detail in our later classes.
Sure. Thank you.
Yeah. Yes, Sharvan.
Hey, the final question I have. So nowadays we have a kind of cloud APIs, right? When it goes to the cloud, right? So how the like a switching will be? There a kind of same. It will go a same. It will follow the same OSI layer, or
Yes.
a kind of something different.
Yes. Everything works on OSI TCP layer.
Okay. So the cloud part, right, where it stays. Because example, if I have an access point, my mobile phone is connected with the access point. When a data goes from access point to the cloud server, right? So that particular server where it follows.
It's a server. It's a data center. It's what is a server? Server is basically a big device.
Okay.
It's like your PC.
Okay. So it's kind of, it will be switching the data from.
Yes. It will be switching, or it will be routing, or forwarding, anything.
Okay. Thank you.
Yeah.
And the question, like, my audio is fine now?
Yeah, it is fine.
Oh, you are audible. Okay.
Yeah,
Thank you.
All right. So thank you for joining today's class. And it went long because it was an introductory. So from tomorrow, we'll just have class for 1 hour or 1.5 hours, not more than that. All right. Thank you for joining today's class. Thank you and have a great day. See you.
Thank you.
Thank you, sir.
Thank you.